Imagine standing before a mirror that doesn't reflect your face, but time itself. A mirror so powerful it shows not who you are, but what everything once was. That's the mission of the James Webb Space Telescope, humanity's most ambitious attempt to see the universe as it existed in its first breath. It was built to trace the glow of creation, to watch the first stars ignite and the first galaxies assemble out of darkness. But when Webb looked deeper than any eye before it, what it found was not a nursery, but a paradox. Not cosmic infancy, but maturity far too early. The images that returned didn't just astonish scientists, they shook the foundations of cosmology itself. For nearly a century, astronomers believed they understood the sequence of the universe. The Big Bang, then the long dark age, then the slow birth of light. Stars forming, gathering into galaxies, galaxies merging, planets coalescing, life emerging. A tidy timeline, unfolding step by step. And by logic, the farther you look back in time, the simpler the cosmos should appear: wisps of hydrogen, dim embers, scattered chaos. But when Webb turned its golden mirrors toward what was thought to be an empty void, it found the impossible. Not a blur. Not a ghostly trace. But a galaxy, structured, rotating, and luminous with countless stars. And that was only the beginning. One by one, more galaxies appeared, mature, complex, and ancient beyond reason. Some shaped like spirals, others hosting massive black holes blazing at their centers, all existing when the universe should have been far too young to build them. It was as though someone had fast-forwarded the cosmic clock billions of years ahead. When Webb captured one such galaxy, located more than 13 billion light-years away, astronomers expected a faint haze, the earliest stirrings of order. Instead, they saw brilliance, graceful arms spiraling outward, clusters glowing like jewels, a dense heart bursting with energy. This wasn't a galaxy under construction. It was finished. Alive. According to every model we've built, this level of organization shouldn't appear until billions of years after the Big Bang. And yet, here it was, less than a few 100 million years old. It was like discovering a skyscraper standing tall in a world where bricks had not yet been invented. To grasp why this is so shocking, consider how galaxies should form. At the beginning, matter was diffuse, a thin fog of hydrogen and helium. Gravity gathered that matter into clouds. Clouds collapsed into stars. Stars aged, exploded, scattered heavy elements, and after endless cycles, galaxies gradually took shape. But Webb's observations tell a different story, one of acceleration. The early universe didn't crawl toward complexity. It raced. Stars were born and died in cosmic blinks, enriching space with oxygen, carbon, and iron, the fingerprints of life. That means entire generations of stars had already lived and perished long before they were ever supposed to exist. And in those ashes lay the same ingredients that build planets, atmospheres, and oceans. The universe, it seems, was never quiet. It was a furnace, burning, collapsing, and renewing itself with breathtaking speed. Then came a finding that defied even the wildest predictions. A supermassive black hole, billions of times the mass of our Sun, sitting inside a galaxy formed just 400 million years after the Big Bang. Black holes, according to every model, are supposed to begin small, fragile seeds of gravity born from the deaths of stars. They should take billions of years to grow into giants. But the James Webb Space Telescope found something that defied that rhythm. In the earliest moments of cosmic history, just a few 100 million years after the Big Bang, Webb's golden mirrors captured the light of a monster. A black hole billions of times more massive than our Sun. Ancient. Fully formed. And impossibly hungry. No known mechanism could make a creature like this so soon after time began. Stars hadn't lived long enough to die. Matter hadn't gathered fast enough to fall. By every law we understand, it shouldn't exist. Some scientists now believe these giants are not the remains of stars at all, but primordial black holes. Objects born directly from the folds of space-time itself. Echoes of the Big Bang, still feeding on the remnants of creation. Others whisper that something unseen may be at work. Dark matter, the invisible scaffolding of the cosmos, perhaps guiding growth through unknown gravitational rules. A few go further still, daring to suggest that gravity itself behaves differently in those ancient epochs, that the very constants of nature may have evolved. Whatever the explanation, these aren't small footnotes to physics. They are rewrites of reality. And with every Webb image, the mystery deepened. The telescope began mapping the universe not as random noise, but as pattern. Subtle ratios appeared in the vastness, repeating spirals, filaments, and web-like geometries connecting galaxies across billions of light years. Where chaos was expected, structure emerged. A kind of cosmic rhythm, mathematical, deliberate, elegant. It was as if the universe was not an accident of chance, but a composition. A song written in energy and matter. A design etched into the very code of spacetime. Then came an even stranger revelation. In the cold void between galaxies, where no light should linger, Webb detected complex carbon chains, the molecular scaffolds of amino acids, drifting freely through the dark. Not tethered to stars. Not bound to planets. But floating alone, for over 13 billion years. It means the chemistry of life didn't wait for Earth. It was here, from the beginning. Life, it seems, may not be an accident of circumstance, but a built-in feature of the universe itself. And then, the image that shook even the most skeptical minds. Astronomers called it the flower. 6 galaxies perfectly arranged in a ring around a seventh, each equidistant, rotating together like petals around a luminous heart. The symmetry was flawless. Too precise for random gravity. Too elegant for coincidence. Some insisted it must be an illusion, the result of gravitational lensing, light bent by invisible masses. But others stared at the data and felt something deeper, as if the alignment wasn't just natural, but intentional. A pattern that seemed to say, "Look closer." A formation that almost felt like it wanted to be seen. And then came the question, the one no one wanted to speak aloud. What if observation itself plays a role? In quantum physics, the act of measuring can alter reality, collapsing a wave of possibilities into a single outcome. What if that principle doesn't stop at atoms and photons? What if consciousness, awareness, ripples through the universe, shaping what it perceives? Some Webb data showed subtle discrepancies. Tiny misalignments between exposures. Shapes that appeared to shift, just slightly, between observation runs. Most wrote it off as calibration error. But a few quietly wondered, what if the universe isn't just being seen, what if it's responding? What if by building Webb, by gazing so far back that we touched the dawn of time, we didn't just observe creation, we stirred it? Because Webb has not merely shown us older galaxies or larger black holes. It has revealed something far more unsettling, that the universe is far more self-aware than we imagined. We see galaxies that formed too early. Black holes that grew too fast. Chemistry that began too soon. And patterns that feel too precise to ignore. These are not small curiosities, they are hints of a deeper order. A cosmos that may not just contain meaning, but generate it. Perhaps what Webb uncovered was not simply the universe's ancient memory, perhaps, for the first time, the universe remembered us. So now the question has changed. It is no longer what did Webb see? It is, what saw Webb? If that thought lingers in your mind, you're not alone. Because every time we point a telescope into the dark, we are not just looking outward. We are also inviting the cosmos to look back. And maybe, just maybe, the next signal, the next flicker of light, the next pattern hidden in the noise, won't simply tell us where we came from. It may finally show us who's been watching all along.